Please find your seats so that the presentation.
Well, tonight we're very pleased to have Paulette Epstein as our main speaker. She is the planetarium coordinator and staff astronomer at the Michigan Science Center, which is to be distinguished, she tells me, from the Detroit Science Center. Two separate organizations in the same building, sharing some of the same staff. She grew up in a small town outside of Madison and attended the University of Wisconsin, Stevens Point, where she obtained a bachelor's degree in physics, my first love. She did 4 years of undergraduate research, including light curves of asteroids, galaxy evolution, dark matter, and hydrogen alpha studies. Paulette decided to make a career in education, inspiring curious minds of all ages. I guess that includes me. She has worked at 4 planetariums, including the Adler Planetarium and currently at the Michigan Science Center Planetarium. Tonight, her presentation is inspiring the next generation of scientists. Paulette?
Thank you so much. Hi, everyone.
Hi.
All right, before I start my presentation, how many of you are traditional educators? Raise your hand. Oh, we've got a couple. Okay, I'm sorry. So I'm a non-traditional educator. I educate people in a planetarium, and I love non-traditional education. Classroom, maybe not so effective. So today what I'm going to do is I'm going to talk a little bit about some of my experiences that I've had sort of in my research and stuff like that, sort of how I've gotten to be a non-traditional educator that I am today. And you're probably looking at me going, wait a minute, what experience? You look like you're 12. Yes, I do look very young. I'm probably the only 25-year-old who still gets carded when I go to the movies. I want to start by sort of talking a little bit about my background. As he said, I've done 4 years of undergraduate research, starting at the University of Wisconsin Stevens Point. This is actually my first sort of research excursion. I went to Kitt Peak National Observatory. This is me underneath the 0.9-meter telescope. Got to use it, got to fill the dewar every 8 hours because I was the undergraduate and I had to wake up in the middle of the day to fill the dewar. So it was really fun research. I was able to establish the light curve of an asteroid called Tim Hunter, as you can see right there. And unfortunately, I was not able to finish my research because my professor took a job in administration. Ooh, administration. But my research was basically just looking at the X term right there for, how many ever hours I worked on it. Every single day in lab. It's kind of sad. Here's me presenting some of my research in Boston. My research was the photometric properties of isolated face-on spiral galaxies. So basically what I did was I took isolated face-on spiral galaxies, put them into a code, and spit out something that looked a lot like this. In the center right there, you can see the total model. It pulls the light apart so you can separate the bulge, the disk, and the bar, and sort of understand how these galaxies evolve over time. We picked isolated galaxies because my research professor had actually done non-isolated galaxies that had interacted, and we wanted to try and see sort of what the difference was between the isolated galaxies and the galaxies that had interacted. By the time I graduated, we went through about 40 of these. The code takes about 8 hours to run, and the cleaning of the images takes like 8 hours. So 40 by the time I graduated was not too bad. I also built dark matter detectors. Building dark matter detectors is it sounds like a lot more fun than it actually is. So I got to sit in a clean room, as you can see right there, actually depositing germanium, tungsten, and silicon onto germanium pucks, taking that down to a chemistry lab, then etching out the microcircuits to something that looked kind of like that. So these are actual detectors that go into the Sudan Mountains in Minnesota. That's one of the CDMS detectors. Now these detectors work by two different detection methods. Well, actually, sort of one detection method. They're hoping that a dark matter particle will come in and weakly interact with the matter that's inside and sort of break some electrons loose. When that happens, they'll go down to the bottom and they'll be picked up by the microcircuit at the bottom. At the same time, they're hoping that it knocks into the germanium crystal and will knock some phonons loose, some vibrations, and those will actually be collected by the one on the top. I also got to Arecibo. Got to go to Arecibo, so you guys saw a picture of that already. And there I did hydrogen alpha research, which was a lot of fun. We were looking for cold galaxies. So, cold galaxies are out there. It was really fun when you just sat in a room and, hey, there's a peak. Yay! We're all excited. So, I loved doing all of this research, but I needed something more. I needed something sort of where I wasn't just sitting in a lab all day. I wanted to interact with people. Well, while I was at my university, I worked at the Adler Planetarium for 3 years. And it was my first planetarium. Yes, it still has a star ball. To this day, it still has a star ball in it. And it had many, many slide projectors, which is where I got all of my experience with slide projectors, or at least the first part of my experience with slide projectors. And then from there, I graduated from college. I was on my track to go to graduate school, and then I had a professor not send a letter of recommendation. If we have any professors in here, never ever do that. So instead of going to graduate school, sort of blessing in disguise, I ended up going to an internship down in Florida, where I worked at the Adler Planetarium. It was my first interaction with sort of full dome video. From there, I went back up to Wisconsin. I actually lived in Milwaukee, worked in Chicago. Yes, that's as miserable as it sounds. But I did work at the Adler. It was a lot of fun, and the reason I loved working at the Adler so much was because I saw so many people come through the doors. They had 3 theaters. Each of those theaters seats 200 people. So every single day I saw thousands of people and tons and tons and tons of kids. And all of those kids left so super excited about astronomy. Now I'm here at the Michigan Science Center. That picture was actually taken for a Model D article that I was in. And every single planetarium should have a picture that looks like that. Every astronomer should have a picture that looks like that. A lot of fun. Was not taken, that's not photoshopped. He actually took a flashlight and painted me with light while he was taking the picture. So that I thought was really cool. So working at the Michigan Science Center is a ton of fun, and I love trying to inspire the next generation of scientists. But how do we actually do that? How do we actually inspire that next generation of scientists? Well, we do that with hands-on activities, which you sort of see here, things that kids can actually see. Kids can actually, well, they can't actually touch that one, but we have other things that they can. When you talk to kids, you have to talk to their level, but of course not talk down to them. You know, with kids, you'd be surprised at how incredibly smart they are. You'd be surprised at how many 5-year-olds I have asked me, what is a black hole? And you know, that's really hard to explain to a 5-year-old, but you have to talk to them and talk at their level, but never condescend, because kids hate that kind of stuff. And if you notice that picture, that's actually from Astronomy Beach this year. which by the way was a very, very fun event and I think very effective in inspiring the next generation of scientists. There were a lot of kids there that had a blast, especially with the Andromeda story. I'll have to learn that one. So the things that we're telling them about don't need to be new, but they do need to be relevant. So when I first started at the Michigan Science Center, we had a show called Little Star, which was made in 1986. Now, you may think, oh, that's not that long ago. Well, one, that's before I was born, and two, Pluto was still a planet. So kids were watching this sort of film and going, okay, you just said Pluto's a planet, now I don't trust anything you're going to say. So we have to tell them things that are not necessarily new, but they really need to be relevant. And a day where, you know, the moon landing and the shuttle missions, in their minds, it's ancient history. So they want to hear about the really, really fun stuff. They want to hear about black holes. They want to hear about dark matter. They want to hear about those questions that really haven't been answered. Which leads me to my next point, unanswered questions. Kids love hearing those unanswered questions. Things that scientists right now are trying to work on. They really, really love hearing about them. And they really love hearing that they are going to be the ones to solve them. So while I was at the Adler, one of our scripted shows actually had this built into the script, saying dark matter is just one of the many mysteries of this universe that we are facing. Some of them will likely take the next generation of scientists to solve. Perhaps someone in this very room. And one day I heard this little kid pipe up, "Mom, is that me?" It was awesome. It was fantastic. And after the show, the mother came up to me and was like, she really wants to be an astronomer. So you give them the unanswered questions and tell them they're going to be the ones to answer them. They get excited about it. They also get excited about stuff that's in the news, like Pluto. As these images come in, kids get so excited. So we put some of these images into some of our shows, and these kids could not stop talking about Pluto after we did that. They could not stop asking me questions about Pluto, like why it's not a planet anymore. That's a sad question to answer, but a question nonetheless. And you know, I sort of like Pluto not being a planet, please nobody boo, because it's a teaching moment. When kids come up to me and ask me why is Pluto not a planet anymore, I'm able to tell them why, and use it as a teaching moment to talk about other things like Ceres and Uranus, and all of the other Kuiper belt objects. This is my favorite image of Pluto, or one of my favorite images of Pluto. You know, New Horizons fly past. Hi. Now the next image that goes after this usually is a little crying face as New Horizons flies away, but I don't like to think about that. One of my other favorite images of Pluto is Pluto. There's a Pluto on Pluto. That's exciting and fun, and something that kids can relate to. I know Mickey Mouse probably isn't the most relevant anymore, but it's still something that they can relate to. They're also excited about Mars, because Mars is one of our nearest neighbors, and there was the discovery of water. Although when I read on Reddit that there was water on Mars, I thought, well, of course there's water on Mars, because it's the image I can't see. But then we actually found out about the discovery, which is awesome. And when we get excited about astronomy, when we get excited about science, kids get excited about it too. So here's some of the kids having a lot of fun in my planetarium. I developed a couple of new shows. Interaction is the best way that kids learn. If you just sit and you lecture at them, they're not going to pick anything up from it. But if you ask them a question, a real question, not a yes or no question, not a question that necessarily has an answer, they're going to think about it. They're going to be able to respond, they're going to learn something from that question. And another thing that kids really love is the experience. So in our planetarium, we have something called the Mobius strip. And if anyone has been on the movie strip, you know it is nauseating, but kids love it. It is like a roller coaster ride through space. We actually tell them that we're hitching a ride through a wormhole back to the Earth, and they have so much fun. They leave the planetarium being so excited, having so much fun, and that's what they're going to remember. They're going to remember the experience, not necessarily the information. I know when I went to the planetarium when I was a kid, I didn't take any of that home with me. Now, the reason that I said that traditional education or traditional teaching in a sense is because, or at least for kids that are younger, at least for, I'd say younger than 6th grade, is because if you take a look at the GLICs for Michigan, the science standards for Michigan, they don't learn about why the sun rises and why it sets until like, I think it's 3rd grade. Yeah, you know it. It's like 3rd grade by the time they learn that kind of stuff. And that's something that they should be learning a lot younger and a lot earlier. Astronomy just barely exists in those GLICs. And that's really, really sad. So it's upon us and you guys to inspire these kids and to teach them a little bit about astronomy. Get them excited about it so they'll go home and they'll learn it for themselves. Or give them the tools to learn it themselves. There are so many tools out there. We've got tablets, we've got cell phones, we've got all of that stuff where kids have astronomy at their fingertips. The app that you were showing, I got one just like that called Baby Sun, where I take a look at the solar weather every day. And kids can do that too. If we give them the resources to look at that, they will. They definitely will, and they get really, really excited about it. This is one of my favorite pictures because kids are naturally curious. They just are. So that's why science is such a wonderful thing, because it sparks that curiosity. It gives them something to think about, something to do. And of course, you know, it's not just kids. Sometimes it's the big kids too.
Question.
But that's why at the Michigan Science Center we like to say that we inspire curious minds of all ages. Doesn't matter how young or how old you are, you're still curious. You still want to learn those things that are out there. And like I said, I try to inspire the next generation of scientists by telling them about a lot of my experiences. If you tell a kid that you did something really cool, like going to Arecibo, I got to climb up on the little thing at Arecibo on the top part. I got to go in the dome and check out the detector, which was really cool. It was terrifying because I looked down and I saw ants below me, because some of the other students were actually going down below the dome. It's 50 feet from where I used to land to where the kids, or to where everyone else is. So I looked down and there were ants. But if you tell kids that you get to do stuff like that with a science degree or anything like that, they get excited. They're very happy. And hopefully they're inspired to become sort of the next generation of scientists. Kids are our future. And it's very, kids are our future, and we really, really do need to work hard to get them excited about science. I know a lot of kids get to about, I think it's 5th or 6th grade, and they go, I hate math, I hate science. I don't know what it is about that age, but they're just not excited about it. The curiosity sort of subsides. Like they like science and they like math, and then they're sort of shunned by their friends. So we need to pull those kids out and try and put them in the spotlight. Tell them that it's okay if they like science, and tell them that it's okay if your friends like science too. So, like I said about the experience being the best part of inspiring the next generation of scientists, I just created a new show at the planetarium for preschoolers. How much science are we going to teach preschoolers? Not much. But we have them come in, we have them stomp their feet, clap their hands, they turn the sky all sorts of different colors. I introduce them to Ursa Major and Ursa Minor, the big and little bears, and the mama and baby bears up in the sky, and introduce them to sort of what the planetarium was all about, what astronomy was all about, study of stars and planets. Introduce them to some of the planets we can see up in the sky, although right now, unfortunately, that's none of them at 10 o'clock at night. But we are definitely able to get those kids excited so that the next time they see us, they remember what they saw, what they got excited about. We had campers this summer that saw me every single week. They saw the same planetarium shows every single week. But they still had fun every time. We also did a lot of astronomy demos with them, stuff that's really, really hands-on. Because, like I said, standing there lecturing at kids isn't going to get them very far. But if you give them the tools to do something fun, they'll do it. And they will have fun doing it. Alright, so I want to ask you guys, do you guys have any fun experiences with kids? Do you have anyone willing to share? Yeah, go ahead.
Yeah, there's several of us here that are outreach that we go into schools. We're also associated with the Boy Scouts, Girl Scouts, and Cub Scouts. Look, we put on presentations to literally thousands of kids every year. And like you mentioned, the thing that kids look for are, when you get things that captures their imagination, things like how big things are, how far things are away. We talk about time travel, look at stars. We talk about, actually one of the things that gets the kids most interested is when you give them an assignment. I talk about, what water bears are, tardigrades, extremophiles, and we give them assignments. I say, we tell them a little bit about this. We tell them, okay, it's okay, go home and use your computer. Now get on to Google or Yahoo. If your parents say it's okay, and enter in water bears. And the kids will come back, next time they see me, say, oh, that was so cool, that all these creatures that can survive right here on Earth in conditions that you wouldn't think they could survive, so that maybe there is life out there, possibility. And things like that, get kids interested. If you make it dry and boring, they will be bored.
Right. So it's funny you mentioned that because, there's things that live in conditions that we never would have expected they'd be able to live in here on the Earth. And we just discovered water on Mars, flowing water on Mars. Who knows, there could be extremophiles on there, and those kids could be the ones that actually discover those. I think, way in the back.
My son is 3, and I'm reading a lot of astronomy books. And he knows all the planets. He knows about galaxy and black holes and satellites and rockets and space shuttle. He loves it. He loves it. And he really loves it. They're never too young to start learning. And nowadays, when I'll show him the planet, I'll say, what planet is that? That's Saturn. That's Mars. He's 3. He knows. It's really good.
Yeah, it is incredibly amazing to just, like you said, 3 years old. And that's about when I got into science too. My dad would take the couch cushions off, we'd go watch the Perseids. And that's why I'm an astronomer today, is because of stuff like that. Yeah.
The last year and this year, I have twin grandsons who are 10 years old. And I made a point to make sure that they saw that partial solar eclipse last year through telescopes and with others working with it. And then, of course, this lunar eclipse that happened a couple of days ago. I had to bargain a little bit with Mom and Dad about the time factor involved. But I said they should release it, and we were fortunate enough to see it. They kept going, cool, 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 look at that, cool. I loved it. It was great. That's the hands-on approach, what you're talking about. You can tell them all about it.
Right.
Show them.
Yeah. And that's why, because I know you guys do a lot of telescope viewing out there, which is awesome, because we give kids that may not have a chance to look through a telescope, especially in Detroit, because there's a lot of kids that'll never have that chance unless someone brings it to them. So that's awesome. Yeah.
I have a kind of an interesting twist on this whole getting kids interested and having them get into astronomy or physics or whatever. It was actually my oldest daughter, who at the time was sort of kindergarten, preschool age, and her and I were in the backyard one nice clear night, and we were just sitting, reclining in these lawn chairs, looking up at the night sky. Nothing especially exciting or anything like that, just kind of enjoying the view. And my daughter said to me, "Dad, how far can we see?" And I thought about it for a minute, and I thought, well, the horizon, that would be like 20 miles. If you're in an airplane or on a mountain or something, maybe you can see 30 or 40 miles or, more. But while I was processing that, I'm at the same time looking up at the moon and the stars and thinking, wait a minute, 240,000 miles to the moon, 93 million miles to the sun. And that was what actually got me really interested in doing the research and figuring out, okay, how far is far, how big is big, how small is small. And it wasn't really like an overwhelming, all of a sudden kind of a thing that hit me, but it was like that little inkling of a gnawing or something in the back of my brain. It just kind of kept rolling until I eventually started getting much more serious about getting into astronomy and figuring out all of these questions. So it was kind of a reverse situation.
Kids ask some of the most amazing questions that I never, ever, ever would have thought of. And, sometimes there are tools for engineering and stuff like that. So you give them a problem, you ask them how would they solve it, and they'll think of a way that we never would have thought about, because our brains are so one direction. As we get older, it gets worse and worse. And our imaginations just aren't what they used to be. And kids, they let their imaginations run wild. That's awesome. And they really come up with some very, very interesting ideas.
Can you give us some examples?
Oh, let's see, an example of a question that a kid has come up with. Well, I've definitely had some kids ask me, what happens inside the black hole, which, is the question that you get all the time. Then he's like, all right, so I don't know what happens inside of a black hole, but what if we had a spacecraft with something that could transmit faster than the speed of light? It went in the black hole and it was transmitting out, and what would happen? And it's like, well, it can't happen, I'm just kind of thinking it can't. But this kid his imagination was going crazy, and he had sort of no boundaries to where his imagination would go. And he wouldn't take no for an answer. It was really kind of interesting to hear him come up with all sorts of different things to try and figure out what really happens inside a black hole. So he's going to be the kid someday to come up with
Did you see the movie Interstellar?
Yeah, the most not real part of that movie, or the most fake part of that movie, is kind of being an astronaut, but
That's exactly what I said.
yeah.
Now, one thing we can do as a club, and I don't know whether you're encouraged to do this at the Science Center or not, but what time you got here, did you notice that boy, the 13-year-old boy that was here a little while ago, had to leave?
Yeah, I saw that.
Okay, well, he was at one of our events, and his dad said he was very much interested in astronomy, so he called me up at home, and I invited him to come down to the astronomy club, and he came here and he joined tonight. And also, my own son is a Boy Scout, and he's a member of 3 clubs, and what he does is, once the boy gets astronomy merit badge in Boy Scouts, he says, now you're good enough to be a member of an astronomy club. And so now we have, I think, 3 or 4 boys who are members of our club who are Boy Scouts. But once the kids come to you, and it's very obvious the kids that are really into this, love astronomy, what do you do with them? You say, just capture them there, say, okay, now you're on your kid, Have you ever considered saying, here's a list of the astronomy clubs in the area, there's 4 clubs here, and say, why don't you have your mom or dad check out some of these clubs, and see what they're like. We've had several kids we, found who are just really into astronomy, whether they're public scouts, working even in schools, and we say, do that. We've had several kids that have come by and got their parents involved, whatever. Because I think sometimes the next step is not taken. We just say, okay, show them all this stuff is really cool, okay, time to go, there's the door, goodbye.
So I haven't thought of that. That's a really good idea. So I've only been here since January. I'm still brand new to the area. And so I'm just sort of starting to learn all of these things, but that is a really good idea how to do that. Normally with the kids, I tell them a couple of websites that they can go to for more information. There's a citizen science project that the Adler Planetarium actually does called zooniverse.org. And I send kids towards that because on zooniverse.org you can classify galaxies, you can try and find exoplanets, asteroids, yeah, as well, and it's something that they can actually do, and they are then being an astronomer. They're finding all of these objects. So I send them to zooniverse.org, and then whatever questions they ask, especially if I can't necessarily answer them, I try and give them a direction to go into at least. That's a really good idea.
That same boy, he also mentioned that he was on the Science Olympiad. He came in 5th place in the state in his group. And I also was in the Science Olympiad. So I think that's something they need to promote more in schools. If there's kids that have interest in science, get them into a club after school hours or whatever, get them into those type of things. Because I think the kids need to be led to the next step.
They do, and I actually used to work at the Science Olympiad in Wisconsin to have these kids. I used to work, they did air cars, and man, some of the designs they came up with. One of them went really, really fast. They didn't have a bumper at the end though, so it just kept flying. And you couldn't do his second run, unfortunately, but it was really fast, so.
Where were you in Wisconsin?
So I grew up outside of Madison, and then I went to University of Wisconsin-Stevens Point, which is at 44.5 degrees north latitude.
And do you have access for the kids that you work with to Yerkes?
We did not have access to Yerkes. So Yerkes is in the southern part of the state, and I was right in the middle.
Well, that's the University of Chicago. Right?
Yep. So I think you have your hand up.
I'm just going to mention that out of Kensington, that's one of the great attractions for me and for a lot of us.
Oh, yeah.
I've got a lot of kids out there, and you've got your own telescopes, and you're looking at something. And one of the things I found interesting was with kids, the 7, 8, 9, 10-year-old kids, was they'd always ask, how far or something, and it's kind of hard to describe that. One of the things we were looking at, I think, was Saturn, and they asked somebody asked how long the year was on Saturn. And that's an interesting question, and I forget what the answer is, but 29 years, okay. So I said, that means you would be in school, your school year would be like 17 years long, but you'd have a long summer vacation. And they can all relate to that kind of stuff, and the guys got a big kick out of stuff like that. Or I asked them one time, we were looking at Alberio, blue and gold star, and asked the kid a question, why is one star one color and why is another star another color? And incredibly, a lot of those kids have the intuition to know one's hotter than the other, which is the right answer, and it's kind of interesting to see kids in that state.
So a fun thing with the hot and cold stars, ask them, all right, what color is the faucet when you wash your hands? What color is hot and what color is cold? They'll tell you red and blue. And then you tell them, okay, now switch it. And that's what stars are.
That's what my grandfather did.
But just being able to relate something to them that they know a lot about, because I mean even the young ones know, all right, red's hot, blue's cold. And to be able to, I've told that to some adults, and they love it. They absolutely love it. One of my favorite analogies is the Milky Way galaxy is flat, like a chocolate chip pancake. If you lived inside of a chocolate chip pancake, you'd be able to see the edge of it, and you'd be able to see a few chocolate chips on either side. But because we live inside of it, that's all we're able to see. Now, if you were outside of that chocolate chip pancake, you'd know it's chocolate chip pancake. But because of where we are, we don't know what it looks like. So analogies are a really great way to get through to kids. Yeah.
So when showing kids things through the telescope, it seems like asking them questions is very critical, because for one thing, it confirms whether or not they're actually looking at it.
That's the point.
Because a lot of kids will say that they see something, but they're not seeing anything. And that can be, and they feel like they're under pressure to see something, so they say that they see something, even though they don't. And asking the questions helps
It
figure
does.
out, but it also gives them the opportunity to, think creatively, like with Adler or colors. So.
And asking them what they see before you tell them what they see can be very helpful. Because then they can tell you what they see, and then you can go, all right, well, do you see this and this? And it's like with that one, do you see a yellow star? Do you see a blue star? Are they moving? That one you're just looking at it.
One thing that's really amazed me is how many kids look through a telescope, and you don't tell them this, but they'll look through it when they're looking at the moon, and say, it's reversed. Here's what it through a prism. And it gives you an opportunity to explain why it's reversed, but I've always been amazed how many kids will pick up on that. Most adults don't pick up on it, but kids will. It's just very obvious to me it's reversed left to right.
Yeah.
Yeah, I really like the wow factor. When both people of any age, both young and old, look through and they've never seen, a significant magnification and anything. You don't need perfectly dark skies. If you got the moon and brighter planets and brighter stars and stuff, and it just goes wow, And something I experienced, after I got my first little telescope in junior high, and see friends and neighbors and all just look and this is something here, And then you kind of fires their imagination, and then the questions start coming, and then it helps me to provide these answers that depending on the age of it. And these analogies about relating distances that we can experience on Earth, to what the distances are in the sky and everything, and how long it takes for light to come here. I'm thinking about 29 years for the year on Saturn versus you have to go. You do little hand diagrams, the sun's here, Earth's here, takes a year for us, but those planets out there take so much longer.
Mm-hmm. Yeah, and I think I saw a hand up, yeah.
One of the things I tell anybody who's looking through my telescope is take your time, look. The longer you look, the more you're going to see. And I happened to be out at a star party out at Island Lake, which is just across the Red River from Kensington. And there was a boy, maybe 10, 12 or that. Look, I was looking at Saturn, and he saw it, and he was really looking at it, 10 minutes later he was back, he was literally dragging his mother. You've got to see this, you've got to see this. And so she looks through the telescope. She didn't say a word. She went around to the front of my telescope to see if I had Saturn on the front of the telescope.
So see, we got a picture. I worked in an observatory while I was at my university, and that was the first thing any college student asked me. They were like, so that's a picture, right?
Mm-hmm. Yep.
Yeah, totally. That's why I have this 16-inch telescope up here to look at pictures. But it is very interesting that you mentioned that kids are a lot more curious than necessarily their parents are, and you tell them to look for longer, they'll see more. One thing that I really like to teach kids is averted vision, looking with the corners of your eyes. And one of my favorite things to show them, up in the sky, in the planetarium sky especially, is the Andromeda Galaxy. Because they can see that for themselves if they're far enough away from city lights. Now, unfortunately, I'm teaching them how to look at the stars in downtown Detroit, so they're never going to see that unless they actually go up north. But you guys are really lucky to live in Michigan, because getting away from city lights is really easy. My husband and I went up to Traverse City, and I've been living in the city for so long now. We were living in Milwaukee, now living in Detroit. I looked up and I'm like, whoa, I forgot that the stars actually look like stars. And not, well, in my planetarium, unfortunately, they're little green blobs, but that's a whole other story.
I have a presentation I use called Size and Distance in the Universe. And what I try and do with the kids, particularly adults love it too, but the kids, is try and give it a reference that they can get an idea, like in distance, that if you travel at so many miles per hour, how long would it take you to get to whatever it was? I use 60 miles per hour because most of the kids have been in a car that's gone to Florida, for example. And then we just go through that. And then, after I get up to the trillions of years, which is the larger things, then we go back and let's use another standard that is to using the speed of light. And one of the ways you can do with the kids today is with cell phones, the cell phone signal is radio signal that travels at the speed of light. And so you can do that also with the same thing you just did in miles per hour. And that kind of gives them a reference point, and now they go, whoa, and that's the thing. So that's another tool that we use with children as well.
Yeah.
And of course, parents are just as stunned by it too, because they have no clue. So.
Well, it's funny using a reference, because I'm using the New Horizons. It took us 9 years to get to Pluto. Yeah, 9 years to 3 billion miles. Fastest spacecraft ever. And then I go out to the edge of the Milky Way galaxy and say, imagine how long it would take us to get out here.
The same speed.
And you also say comparisons in size. So we have a show where we start with Michigan, and then we talk about some of the asteroids, because there's asteroids in the asteroid belt that are smaller than Michigan. But though if they hit Michigan, they leave quite a crater. And then I bring up Vesta, the size of Michigan, and tell them, well, that hit Michigan. They leave a little more than a crater. We'll stay.
Might ruin our day.
Yeah, might ruin our day. Maybe a little bit. Yeah.
I also want to mention, both my family and my daughter, my grandson, do love the Michigan Science Center. We're glad somebody brought it back into operation. I'm just wondering, where they have the bicycles there trying to get way out to Pluto.
Oh, yeah.
Have they ever made it?
That's a really good question. I'm not sure. They haven't made it since I started. And like I said, I started about 9 months ago, so they haven't made it up there yet. I think we're right around Mars or so.
Yeah, I think they're just past Mars.
Past Mars, yeah. That's a really neat little way to show kids, how far these distances really are in our solar system. Yeah.
I noticed two dynamics with kids that are sometimes frustrating to overcome. I volunteered out at Camp Bert Shirley, the Detroit Public Schools summer camp out in Pinckney's State Forest. And we had one cabin of kids at a time looking through telescopes. And there would be kids who were super interested, and their friends would stop at nothing to try to pull them away from the telescope and to make them feel like they were inconveniencing them by looking through the telescope. And with some kids I was able to overcome that, and with some I wasn't. And it really depended on how much they liked their friends, I guess.
Yeah, how old were those kids?
Well, we had, I think, 2nd grade through 6th grade.
Through 6th grade. I find, unfortunately, that you start to lose them right around 5th grade, right when the hormones kick in. And it's unfortunate, but sometimes you can still keep some of their attention. It's nice when you can slow them up a little bit. It's also nice when they're in a dark room and their friends can't tell who's answering the questions. So planetarium is sort of I sort of have an advantage in that way, being able to overcome a lot of that.
I think we need to like
Well-
rent a Lamborghini and drive it to Stargate before our events, you know?
Sounds fun.
Yeah.
And the other dynamic that's sometimes even worse is when parents are not so interested, and parents want their kids to look through the telescope and absorb all the knowledge of the heavens in 30 seconds, and then they want to pull their kids away and go on to the next activity. And how do you deal with that? I imagine it's a slightly different experience in a planetarium, but it's so frustrating.
It is, and it is really, really frustrating. Basically, I just try to be as excited as physically possible, and I try to get the parents excited. Or sometimes I'll actually call the parents out in the middle of shows. So cell phones are the bane of my existence, because I work in a dark room, and they don't realize that they take out their cell phone and, well, they just lit up the entire dome. I call it Aurora Cell Phonus in the planetarium, and so it's almost never the kids. It's always a chaperone or a parent. And I always call them out, and I always go, I think I see a little bit of Aurora Cell Phonus. Put your cell phone away, or I will eject you from the spaceship.
Bring it down to their level.
Yeah.
I agree with you. I've had a problem with traditional teaching of astronomy. I think that education misses out in using astronomy as a way of teaching everything else. Because you can certainly use astronomy to talk about science, you can talk about math, you can talk about physics, biology, because basically there's astrobiology, astrophysics, astromedicine, all these things. And I found that there's a few schools that the particular teachers are really into astronomy. I've got several teachers I'm very close related to who really go out of the way to provide for astronomy. Most teachers, they are told, do the meat test, teach the meat. I have a real problem with that. But it seems like they need to use, when you tell a kid, for instance, to learn how to do math. Well, to a kid, what does that mean, math? Okay, I can add 2 and 2, big deal. But if you show them how 2 and 2 can be used to solve life's questions and problems, in astronomy, that's a good example. What's the distance to that? You have to go this far, that's farther, this is an astronomical unit. How many astronomical units? So it gives them a chance to see what math can really do for you.
Yeah, and as long as you're within a magnitude, you're fine. Yeah.
What's the chances of you becoming a member of our Warren Club and joining our outreach team?
Let me figure out my job first. So like I said, I've only been at the Science Center for like 9 months, and I'm still figuring it out. Still working like 100 hours a week. So once that subsides, I definitely want to get involved in the astronomy clubs.
Okay, we have first dibs on you.
Where do you live? What city?
Southfield.
Pardon?
Southfield.
Oh, okay.
Were you at Kensington?
I was, yeah. You may have seen me. I was the one wearing the astronomy dress or the star skirt and running around like a chicken with my head cut off. Yeah. Because the Michigan Science Center ran a tent, and so I was running between the tent, the outreach, the top of the hill, the outreach, because we had an outreach table as well where we were doing Star Lab. And I wish I could have gotten to it, but unfortunately I didn't, because I love Star Lab.
Yeah, and you talk about how much of an impediment some adults and some teachers can be. When you hear from things like, okay, we don't want to hear about millions and billions of years or anything. It's like, that's so dangerous. But on an observational level, I've also seen parents complain and grumble, oh, we waited in this line, to look through the scope, and I always saw this little smudge, and they're hauling the kid away by the hand, and the kid wants to see more, and it's like,
But that smudge is like 500 billion stars, 2.5 million light years away from us. That's, like I said, really all we can do is try and be excited, try and get kids to be really hands-on, and that's all we can do. We can hope that they're going to become our scientists someday. Yeah, our advocates.
important to also remember that many of us in this room are adults who haven't lost their inner child. Okay?
Especially you.
I have not. I have not.
Excellent observation.
That's a good observation, and I hope I know.
One of
That's one
the
reason
kids,
we're here.
they can be fun and sometimes they can be frustrating. But some of the best experiences for us is having some of the adults look through the scope. And I remember having some adults in their 40s, and they'd never looked through a telescope. And they were just really thrilled. Don't forget the adults.
Oh yeah, I don't. I think it's as important to reach out to the adults as it is to the kids. It could, like I said, we inspire curious minds of all ages. And especially when I was at the Adler, we had a gentleman who came about every month or so to see the shows, and he saw the same show every time. But he just came in because we had full dome images that would just glide across the dome of like the Carina Nebula. And he thought it was so fascinating and he loved it. And every time he would come up thanking and say, I had a wonderful time, I'll see you next month.
It just came to mind when I have kids look through the telescope, and like we said, you have adults saying, it's a picture, or how are you making that image? I try to really remind people that they're actually looking at a physical object out in space that this thing is pointing at, and like for the Andromeda Galaxy, I'll tell them that, this photon of light has traveled so far, and it ended its life in a way inside your eyeball, converted. You're taking away a piece of the Andromeda Galaxy with you. Every time you look through a telescope, whatever you're looking at, you get a little piece of it. It's really, and especially Saturn, it's just so much more tangible than an image. You really get the sense that you're looking at something that's floating out there in the void. That's the best part.
Especially the
hook.
Yeah.
I looked at a telescope here at Cranbrook, and they have, it's inside, so I saw heat waves coming from it, so I was really sure I was looking at an object then.
Yeah.
In this group of people here, we're very fortunate that many of us have some really fine optical instruments that work in the night sky. But when we did one of the observation nights in Detroit, I took one of my favorite observing tools, which was just a pair of binoculars, and put it on a tripod. And I let some people look through it. And it was amazing how much, not only did they enjoy looking at that, but just the realization that it didn't take a lot of money to be able to see some visions of the night sky through all things, just a simple pair of binoculars. And that really kind of opened up things for them, because now it's not like a challenge like, I can't do this kind of equipment, but a pair of binoculars or something similar to that. Now they can really do some serious nighttime observing and really enjoy it.
Yeah, because I've come across so many people like at Kensington that just assume that a telescope is $1,000, and it's just not true. I mean, but yeah, there's a lot of people that are flabbergasted when I tell them how much I have invested in my scope. It's nothing. I have almost nothing invested in my telescope.
And
But I can still see Saturn.
a pair of binoculars sometimes is the best way to do anything. I'm an astronomer, and I don't have a telescope, but I have a pair of binoculars. So I can still go outside and see a lot of phenomenal objects with just that pair of binoculars. So, and actually, how many of you were at Mary's night, the space party? Because I saw a picture of you guys while I was going through the Facebook
I
page.
think we were the lost representation. That
Okay.
a couple of members came to attend, but not.
It was mostly Ford Club people.
Mostly, okay. Yeah.
Yuri's night at the Michigan Science Center, right out in front of.
By the way, we hope to do that again. And that was getting the adults through the door.
Yes.
That was a night for the adults. And it was, from what I've heard, it was a lot of fun. I was trapped in the planetarium the whole time.
I was trapped outside the whole time.
But yeah. But you guys had fun.
We did.
Oh, yeah.
That was great.
Hopefully we're doing that again next year, so that we can not only inspire the young ones, but also the, of course, the young ones.
I think it helps people to appreciate binoculars if you tell them it's 2 telescopes, right? I think this has been a really neat presentation, novel way of doing it, to a large extent turn it into a discussion where we all participated in the presentation. We ought to have a unique presentation award or something, right? Yes?
I think Paulette had something to say.
Oh,
Well, I mean, I do this, but you guys do it too. I mean, when you go out and you do any of your outreaches, you're inspiring that next generation of scientists and everyone to look through a telescope and learn something about astronomy.
One more question. Who's got the brown jug?
What?
Michigan or Wisconsin? Who's got the brown? The little brown jug.
Uh-oh.
Yeah, I'm sorry you all had to miss the Lions game tonight, but I'm sure you're really not missing much.
You have to show more enthusiasm.
Great, so we will, for those of you who are interested in continuing the conversation, Paulette is going to be joining us at the Red Coat Tavern. So if you would like to enjoy some gastronomy after the astronomy, we will see you down there. It's on Woodward, just north of 13 miles.